This section is a very long section because there's about 4 different skills that we're going to learn in this section. So chapter 3, section 3, we're going to start with long division, and then we're going to go into synthetic division, and then we're going to go into some special cases. And if the video gets too long, I'll pause it at the end of a section, and then I'll go and I'll make another video. Okay? So the first thing we're going to do is long division, and this is long division with polynomials, okay? So this is what we're doing. Remember that in the past we've done addition, subtraction, and multiplication of polynomials, but we've never really divided them. So now we're going to do division, and there's a lot of instructions here, and you can read this anytime you want, but I'm going to go straight to the problem and kind of work it with you that way, and I'll cover these topics as I show you how to do it. So the first thing you're going to see is you have this polynomial x squared minus x minus 2 over x plus 1. That means that it's being divided by x minus 1. So what's going to happen is your dividend is going to go, the top number is going to go into the division bar, and then the bottom number is what you are dividing by. So that's how you would set this up to begin with. Now, one thing you want to look at, and it's mentioned in the slide before, is that you want this to be in standard form. In other words, or in the form where it goes in decreasing order. You want your polynomial to have the highest degree first, which is 2, then 1, and then the constant always goes last. And so if there happens to be a term that's missing, you're going to put a 0 in for that term. And I'll show you when we get to that kind of problem. So in this case, nothing's missing. It's in descending order, so I'm ready to start. So how I'm going to start is I'm going to look at the first term in the dividend, and I'm going to look in the first term in that divisor. And I'm going to divide x squared by x. So, or I can think of it as multiplication. X times what equals x squared, right? So you're like, okay, it's x. Now, I like to put the x above the term in the dividend that has an x as well. That's an x to the first power. So I could do, like I said, x squared divided by x is x, or x times x is x squared. Either way, I'm going to get that x up there, and now I'm going to multiply x plus 1 by that x, and I'm going to get x squared plus x. And just like normal division, remember, you divide, then you multiply, now you have to subtract. So I'm subtracting this entire expression, which really means I'm adding the opposites, okay? And if I do it correctly, my first terms are always going to cancel. So notice minus x plus minus x is minus 2x. And then remember, in regular division, you're going to bring down. So you're going to bring down the next thing, the next term. So you divide, you multiply, you subtract, and you bring down, and then you do it all again. So once again, I'm going to look at the first term here, and I'm going to look at this x. So let's say first term and x, and I'm going to say, well, negative 2x divided by x is going to give me a minus 2. And now I'm going to multiply x plus 1 by that minus 2, and I'm going to get minus 2x minus 2. And remember, I'm really subtracting, which is the same as adding the opposites. And my first term should cancel, and I get 0. Notice I have nothing left to bring down, and I'm done. I know that I'm done when the term that's down here is 1 degree less than this expression or my divisor. So since that's an x to the first, x to the 0, or not having an x, is going to be where I end. So that's my remainder. So I'm pretty much done. So the quotient, if I were to divide x squared minus x minus 2 divided by x plus 1, my answer would be x minus 2. Okay, and so that is my answer. Okay, so I'm going to keep going now to my next problem. And again, I'm going to check it and do the same thing. I know my numerator becomes my dividend here. There's no missing numbers, and it's in order, so I'm good. And my divisor is x plus 3. So again, I'm going to start by looking at the first term of each, and I'm going to divide x squared by x. Well, x squared divided by x leaves me with x. So now I'm going to multiply x times x plus 3. I'm going to get x squared plus 3x I know I have to subtract the entire expression, so it's minus minus. And if I do it correctly, my first term must cancel out. Okay, so I'm going to bring down now. So I divided, I multiplied, I subtracted, and I brought down the negative 2. And I'm ready to go again. So, whoops, sorry about that. So my first terms are the ones I'm going to look at. So I'm going to look at the minus 4x, and I'm going to divide it by x. So minus 4x divided by x is a minus 4. So now I'm going to multiply x plus 3 by minus 4. So minus 4x minus 12. And because I'm subtracting it, I'm adding the opposites. And so the first terms cancel, and it leaves me with 10. And there's nothing left to bring down. Now here I have a remainder of 10. 10 is my remainder. Well, how we write remainders in this long division is we do plus the remainder over the divisor, like that. So it's remainder over the divisor. Okay, that's how we're going to write it. And so the quotient then of this problem is x minus 4 plus 10 over x plus 3. So we keep going. Now we're going to go to a longer problem. Again, same concept though. I'm going to come in here. My numerator is my first term, and notice that my x's go in descending order. 5x cubed minus 6x squared minus 28x to the first minus 2, which is the constant, and my divisor is just x plus 2. So when I start this problem, I'm going to look at 5x cubed and the x, and I'm going to divide 5x cubed by x, and I'm going to get 5x squared. And now I'm going to multiply x plus 2 by that 5x squared. So I'm going to get 5x cubed plus 10x squared. So I'm going to subtract this, which means I'm adding the opposite signs. And so my first term should cancel. If my first term doesn't cancel, guys, I definitely did something wrong. So I have minus 16x squared, and I'm going to bring down the 28x. I'm going to bring down the next thing. And then I'm going to repeat the process. Again, minus 16x. Let me do it in green. And I'm going to divide it by x. So minus 16x squared divided by x is a minus 16x. And now I'm going to multiply the entire x plus 2 by that minus 16x. So minus 16x squared minus 32x. I'm going to subtract, which means I'm going to add the opposite. And I'm going to do 4x is the difference, or well, I'm adding, so it's the sum. And then I'm going to bring down the minus 2, which is the last term in my dividend. And once again, I'm going to do the same process. I'm going to take this first term, and I'm going to divide it by x. So I'm going to do 4x divided by x is going to give me positive 4. And now I'm going to multiply x plus 2 by that 4. So 4x plus 8. It's minus the entire expression, which means I'm adding the opposite of each one. That cancels the first term, and I get a minus 10. I have nothing left to bring down, and I'm done with the work part of it. Now I just have to finalize the answer. So it's going to be plus, and it's a minus 10 over x plus 2. Remember, remainder over divisor. So again, my answer here is 5x squared minus 16x plus 4 plus negative 10 over x plus 2. Now we're going to get to this problem here, and this one has a unique situation here because, again, I'm going to set it up, and normally I would do x cubed minus 1. I'm dividing by x plus 1, and I would be ready to go, but notice that I'm missing things here. I'm missing x squared and x to the first power. I can't write it without filling in what I'm missing. So I'm going to do x cubed, and this is where you're going to add those zeros in that I told you about. So you're going to do 0x squared plus 0x to the first power minus 1. So you're going to use those fillers, okay? The fillers are very, very important. Not so much in this form, in long division, but when we teach you a new form, the next form is called synthetic division. And when you do synthetic, you'll get the answer wrong if you don't put the fillers. So you definitely need them, okay? So again, we're going to start out with the process. We're going to start with the first term and divide it by the first term of your divisor. X cubed divided by x is x squared. And then I'm going to multiply x plus 1 by that x squared. So I'm going to get x cubed plus x squared. And I'm subtracting that. Remember, this is division. So I divide, I multiply. Now I'm going to subtract. Subtract means I'm going to add the opposite terms. My first term should always cancel. And I'm left with that second term. Now I'm ready to bring down the next term, which is plus 0x. And again, the process repeats itself. So I'm going to divide now. I'm going to divide the first term, negative x squared, by x, and I'm going to get minus x. And I'm going to then multiply that to x plus 1. Minus x squared minus x. I just multiplied. Now I'm going to subtract the whole thing, which means adding the opposites. And I'm going to get x. And then last step is to bring down. Okay? And so I'm going to do this whole thing one more time. So I'm going to do the first term divided by the first term here. So I'm going to do x divided by x is 1. So I get plus 1. And I'm going to multiply x plus 1 by 1. Then I'm going to subtract, which means adding the opposites. And I'm going to get minus 2. So my remainder is minus 2. So again, minus 2 over the divisor. So my quotient is x squared minus x plus 1 plus the remainder over the divisor. And that's my answer. So synthetic division is an alternative way to do division. Now, the synthetic division can only be used when you're dividing by, when your denominator is just a binomial, okay? And it has to be a binomial x minus c form. So it can't be x squared. It can't be x cubed. It has to just be x and a number, okay? So unfortunately, or fortunate, whatever, you just can't use it all the time. However, when you can use it, it's much, much easier than the other method. All our examples too, in the other one, we were dividing by binomials every single time. Well, that's not always the case. You can divide by a trinomial or whatever. It's just happened to be that our examples were all binomials. So when you do synthetic division, it can only be division by a binomial, okay? And then again, there's a process for it. There's a list of things here. You are welcome to go back and read that list. What I'm going to do is I'm going to just show you how to do it, and I'm going to teach you what's on this list as I do the problems. So again here, it's like before, right, where you would do this using long division. So I'm going to do it doing long division just so you can kind of see the difference of how simple one is. And you can also prove to yourself that it actually works. So using long division, I would divide x squared by x, and I would get x. I would multiply, I'd get x squared plus x. I would subtract, which is adding the opposites. I'd get minus 2x minus 2. Then I would divide minus 2x by x. I'd get minus 2, minus 2x, minus 2. Subtract the whole thing, which is adding the opposite. And I would get a remainder of 0. And so my answer would be x minus 2. Okay? Now, let's do it using synthetic division, which I just misspelled. So let's try synthetic and see how it looks different. So my divisor is x plus 1. Okay, now remember, the divisor is in the form of x minus c. So if it's x plus 1, it's really x minus negative 1, if that makes sense, right? Because x minus negative 1 gives you x plus 1. So my c value here is actually negative 1, not positive 1. So this is kind of similar to our x minus h in our standard form that we do. Remember, the h value that you see is always opposite what the sign is. Well, your c value is opposite what you see here. So my c value is negative 1. And so I'm going to use this denominator to identify that c value. And then the trinomial, the x squared minus x minus 2, is what I'm going to put up here, but I'm not going to put the variables. I'm putting the coefficients that are in front of the variables. So I have a 1 for x squared, I have a minus 1 for x, and I have a minus 2 for the constant. If any number is missing, like x to the third, x to the second, something's missing, I remember that I put a 0 for that, and I would have to put a 0 in my synthetic division, okay? So anyway, the steps to follow for synthetic division is the first term always gets brought down as it is, okay? So whatever that first one is, it's a 1. Yeah, I bring it down, okay? And then I'm going to multiply the c value here to that 1. So negative 1 times 1 is minus 1, and I'm going to write it in the next column. And then I'm going to add that next column, okay? And then I'm going to repeat the process. I'm going to do minus 1 times minus 2 is a plus 2, and then I'm going to add the column, and I'm going to get my answer. Whatever number is in the last column, that's my remainder, okay? And then I'm going to look at the degree that I started. I started with an x squared, so my quotient is always going to be 1 less than x squared, so x to the first. And this is going to be my new coefficient for that term. So it's going to be 1x, and then after x is just the constant, so it's minus 2. So notice that my answer is x minus 2 with a remainder of 0. And go look at the long division. That's exactly what we got. We got x minus 2, and we got a remainder of 0. So you see that we get the same answer, but it looks totally different. So when we do a few, it'll make sense, and you'll see how simple it is. So here again, I'm doing the same thing. Again, remember that it's x minus c, so x minus negative 3 is going to equal x plus 3, right? So I know that my value is negative 3. So negative 3 goes on the outside, and on the inside, I've got 1, negative 1, and negative 2, okay? Again, I don't have to fill anything because nothing's missing. So I'm going to bring down the first number, and then I'm going to multiply. Negative 3 times 1 is negative 3, and then I'm going to add and get negative 4. And then I go again. Negative 3 times negative 4 is positive 12. I'm going to add, and I get 10. So I know this is my remainder. So when I rewrite this, I started with an x squared, so now this is going to be 1x minus 4. And if 10 is my remainder, I know my remainder always goes on top, and what I divided by goes on the bottom. And so I'm able to write this out, and that's my solution. It's x minus 4 plus 10 over x plus 3. And if I did it long division, that would be the solution. Again, I'm going to go to another problem. Again, here's a large problem. Again, it's x plus 2, so I already know that what I'm going to put out here is minus 2, okay? And then I work with this inside. So I start with x to the third, the coefficient is 5. It goes to x squared, the coefficient is minus 6. It goes to x to the first, the coefficient is minus 28. And then it goes to the constant, and it's minus 2. So these are the numbers that I would set up. There's nothing missing, so I don't need to insert any zeros. And again, the process is to bring down the first number, then you multiply, you get minus 10, you add, it becomes minus 16. You multiply again, you get plus 32. You add, and you get a 4. You multiply again, you get a minus 8. You add, and you get a minus 10. And this is your remainder. I started with an x to the third, so this is going to be 5x to the second minus 16x to the first. And then this is going to be plus 4, that's my constant. And then it's going to be plus negative 10 over what I divided by initially, which is x plus 2. And so this is the long division, or the synthetic division way of solving this. And again, it becomes very, very easy when you do enough of them. Now here we get to the same problem that we did before, where we have some missing pieces, right? So again, we know that we're here, the number on the outside is going to be negative 1, right? Because I'm going to use this for that. Now the top, I have a 1x cubed and a minus 1 constant. If I only put those two things there, guys, it's going to be wrong. My answer is going to be incorrect. Remember, this is like an x cubed plus a 0x squared, plus a 0x minus a 1. And so, yes, I'm going to have the coefficient of 1, but then I got to do 0 for the x squared, 0 for the x, and then a minus 1 for the constant. And now that I inserted those zeros, I'm ready to do this using synthetic division. So the first term gets brought down. I'm going to multiply negative 1 and 1. Then I multiply negative 1 and negative 1. And then I add that. Then I multiply negative 1 and 1, and I get minus 1. And then again, I add, and I get minus 2. And so this ends up being my remainder. So once be careful with those negatives, back and forth. But my final answer then, if I started with x cubed, then this is going to be x squared. This one here is going to be minus x. This one here is going to be plus 1. And my remainder is minus 2 over my original divisor, which is x plus 1. And there's my solution. And so that's how we do it using synthetic division. Now the issue, like I said, is that synthetic division only works when the divisor, you're dividing by a binomial with an x to the first power. If that was x squared, I couldn't use this method. If it was a trinomial or whatever, I can't use it. So this method, the synthetic division, has limitations on when you can use it. So here we're coming to 1, and notice that I have a trinomial in the denominator, which I didn't have originally. I haven't had one like this yet. So again, we're dividing it, but because it's a trinomial, I'm going to have to use long division for it. So I have to use this is my divisor here, and then my dividend. Again, I've got my 2x to the 4th, I've got my 4x to the 3rd, then it goes down to x squared, then to x to the 1st, and then a minus 2. So I always check it to make sure it's in order, that I don't have to put it in the correct order first, and then I make sure that there's nothing missing. So this is in order and there's nothing missing. So I'm ready to start. Now this problem's going to be a little bit because obviously I've got a lot going on here. I start by dividing. Oh, wait a second. I did the line wrong. Sorry. I did the little synthetic division line. So the line here actually goes that way. Okay. So I'm going to start by dividing 2x to the 4th by x squared. So 2x to the 4th divided by x squared is going to be 2x squared. And so I'm going to write it above the x squared over here. I like to have my like terms over each other. So now I'm going to multiply the entire trinomial by 2x squared. So I'm going to get 2x to the 4th plus 4x cubed minus 6x squared. I'm really subtracting the entire thing, which means I'm adding the opposite signs. Okay, and if I do it correctly, my first term has to cancel. Coincidentally, in this one, my second term canceled as well, and my third term is just going to be x squared. So now I'm going to bring down the next thing. Okay, so I've got plus 3x here. Okay, so I'm going to go again, and I'm going to see, okay, what can I divide? I'm going to divide x squared by x squared, right? So I got to get that answer. So x squared divided by x squared is just 1. Now notice that if it's 1, I'm going to kind of write the 1 over here. So I don't really have an answer that's going to go above here. I'm going to end here so I can bring down this minus 2 because I'm going to have a trinomial. I'm going to be using that minus 2. I'm going to multiply everything by that 1. I'm going to get x squared plus 2x minus 3. I'm subtracting the expression, which means I'm going to add the opposite of every term in here. First term cancels, x plus 1. And notice I'm done because what happens is you're done dividing when the degree of this is smaller than the degree of the original. Okay, so I know that I'm done there. So my problem is done. X plus 1 is my actual remainder. It's okay to have an expression be your remainder. So that's going to be my numerator, and my denominator is always what I divided by, which is x squared plus 2x minus 3. So if I write this a little neater without the spaces, my solution here is 2x squared plus 1 plus x plus 1 over x squared plus 2x minus 3. And that's my answer. So the remainder theorem is a special application for synthetic division. Okay, so this is an application of synthetic division. All right, it's a way to use synthetic division where it's going to help you to save time. Now this has like a typo, so I'm not going to worry about this. I'm going to show you what it means. So in math, right, normally if I gave you this problem a long time ago and I said find the value of f of x if x is negative 2. The long way to do this and the way that you were taught in the past was basically everywhere where there's an x, you have to sub in minus 2 and you have to do the math to figure out what this equals. So I'm going to kind of do it for you just so you can see the work involved here. Okay, so negative 2 cubed is negative 8. Negative 2 squared is 4. 5 times negative 2 is minus 10. And we have a minus 7. So then I come here and I get negative 24 plus 32 minus 10 minus 7. If I do all my negatives together, or whatever, let me just go in order. Negative 24 and 32 is 8. 8 minus 10 is minus 2. And minus 2 and minus 7 is minus 9. So the value of the function when the input is negative 2 is negative 9. I could see that as an ordered pair, negative 2, negative 9. I know my x and my y, input and output, however you want to see it. But the value of the function is negative 9. Now let me show you how you can use synthetic division to save yourself all the math. Okay, so in synthetic division, if I was to do this, first of all, if I was to put this long polynomial in my synthetic division, remember I would make sure it's in decreasing order. I would make sure there's no exponents that are missing, like x to the first or something. They're all here. So I'll set it up with my coefficients. It's 3 for x cubed. It's a 8 for x squared. It's a 5 for x. And it's a minus 7 for my constant. Here, they're already giving you the value. It's minus 2. I don't have to do the opposite. If this was in an expression, it would be x plus 2. But when they give it to you just like that, you use it as is. So I'm going to use the number we're looking for as it is here. And I'm going to do synthetic division, just like I would normally do. So I bring down the 3, multiply, and add. Multiply the negative 2 and 4, and then I'm going to add. Multiply the negative 2 and 1, and I'm going to get negative 2, and I'm going to add. And what the remainder theorem says is that the value of the remainder is the value of the function when you plug negative 2 in for x. And notice, when we plug negative 2 in, we got negative 9. So here, negative 2 is our input, and our output is negative 9. And so that was a whole lot easier than doing the math. And so you can utilize synthetic division, and the remainder is going to be the value of the function at that x value. So it's pretty cool. So again, we come over to number 11, and if I want to know the value of the function when x is 4, I could plug 4 in here and here and here and figure that out, or I could use synthetic division and save time. So that's what I'm going to do. I want to know the value when x is 4, so that's the number I'm putting on the outside. And then I notice that I have all my things, they're in descending order, and there's nothing missing. So my coefficients are 4, 10, minus 3, and minus 8. Bring down the 4, I multiply, I get 16. I add it and get 26. I do 4 times 26. I get 104. I add that and I end up with 101. I do 4 times 101. That's 404. I'm going to add. I'm going to get 396. And this remainder is my value. So the value of the function when x is 4 is 396. And so synthetic division with this remainder theorem is a savior for a lot of our math problems. It saves us a lot of time. Okay. So the factor theorem is another great strategy that, or a great application for synthetic division. Again, it's just another way to use synthetic division. And so what happens here is it tells you that if you're ever testing, like we want to know if a polynomial, like a binomial, is a factor of the original polynomial. Well, if we use synthetic division with it and we get a remainder of 0, then we know that it is a factor. And so, again, I'll show you how we use it, but just know that if the remainder is 0, you know that that binomial is a factor of the original polynomial. So let's see what we could do with that. So notice they want to know, is x minus 2 a factor of this large thing? Down the road, right, I'm going to ask you to factor something like this. And you're going to tell me, well, I don't know how to factor that. It's a 4th degree polynomial. I don't know what I'm supposed to do with that. Well, this is going to help you with that. So first of all, we want to know, is x minus 2 one of the many factors of this? So again, remember that if it's x minus c is how we see this, right? Then we know that x minus 2, that the c value is the 2. Right? So I know that 2 is what I'm going to be using in my synthetic division. It's always the opposite of what you see in here. And then I notice all my x's are in order, they're decreasing, and nothing's missing. So my coefficients are 2, 7, -4, -27, and a -18. I'm going to bring down the first one, I'm going to multiply, and I'm going to add. I'm going to multiply again, then I'm going to add, write it in the column, and I'm going to add. I'm going to multiply, I'm going to get 36. I'm going to add, I get 9. 2 times 9 is 18. I'm going to add, and I get 0. So because the remainder is 0, x minus 2 is a factor of the polynomial. Okay? So the answer is yes. Okay? Because the remainder is 0. What's also really cool is now I can rewrite this original polynomial as a lower degree, because I can take this quotient, this answer, these 2, 11, 18, and start writing what's left over. Instead of x to the 4th, it's going to be 2x cubed plus 11x plus 18x, x squared over here, sorry, plus 18x plus 9. And notice what happens when I do that. This was not something I think that you could factor. It had 5 terms. You do not know, you don't have strategies to factor 5-term polynomials. However, notice that when I did it, it went from 5 terms to 4 terms. And you guys can actually factor that. You would be able to factor this now, because you would take this and factor by grouping, okay? I mean, there's other things you might, may or may not, but you could potentially factor this out, okay? And so again, that's the purpose of this, is finding out if something's a factor, and then what you're left with has less terms and may be able to be factored down, all the way down till you get all the factors. So this is just the intro to that. So determine if x plus 3 is a factor. Well, then that means -3 is going to go on the outside, and I'm going to write those terms again, 2 and 7, -4, -27, and a -18, and I'm going to do the steps. -3 and 2 is -6, and I'm going to add. -3 and 1 is -3, and I'm going to add. -3 and -7 is +21, and I'm going to add here, -6. -6 and -3 is +18, and I'm going to add. And again, I know that 0 is my remainder, and so yes, it's a factor. Okay, yes, it's a factor. Now, what am I left with? I'm left with 2x squared plus x squared. No, sorry, my bad. What did I start with here? I started with x to the 4th. Sorry, 2x cubed plus x squared minus 7x minus 6. And so once again, I'm left with a 4-term polynomial that might be helpful to me for factoring in the future, okay, to factor it all the way down. But yes, x plus 3 is a factor as well. And then the last one says, given x plus 3 is a factor of x cubed minus 19x minus 30, find all factors and zeros, then use a graphing utility to graph and verify the zeros. We're going to save this for when we get to your calculator. But for right now, we're going to see it's saying that x plus 3 is a factor. So if we know it's a factor, how we do this is, again, we're going to plug it in. We're going to do minus 3. I could divide it out, but I'm going to do it this way. Minus 3. I'm going to put my coefficients in here. Now notice this is x cubed plus 0x squared minus 19x minus 30. So when I do this, I have to have a 1, a 0, a minus 19, and a minus 30. So come down here, minus 3, multiply, I get 9, I get minus 10, I get 30, and I get 0. So we already knew it was a factor, so we knew this was going to end up being 0. But what I did it for was to get this. If I start with x cubed, I know my next one is x squared minus 3x minus 10. And so now if I'm here, guess what? I can factor that. I already know x plus 3 is one factor. Now I can factor this. I know this is x minus 5 and x plus 2, right? And so now I join that to that, and I know what all my three factors are. My three factors are x minus 5, they're x plus 2, and they're x plus 3. Now remember that my x values, right, whatever makes x equal to 0, makes the equation equal to 0, remember, those are my zeros and my solutions, right? So these are my factors. This would translate to an x equals 5, an x equals negative 2, and an x equals negative 3. And remember, these are ordered pairs. This represents all the places in the graph where the graph crosses the x-axis. And so these are my zeros, okay? So if they ask you for your zeros, they're wanting that. If they want the factors, they're wanting this, okay? But again, when you got this, you probably could not factor that and would not have been able to tell me the factors or the zeros. But by knowing one factor, you're able to make it smaller, and by making it smaller, you're then able to factor at some point or use quadratic formula if it's unfactorable. But you break it down to what you know how to do. And that's all the skills for this lesson. Again, a lot of it is based on synthetic division. So yes, you need to know how to do long division, but synthetic division is absolutely critical because not only do you do it to divide and find quotients, you also do it to use the remainder theorem to find the value of a function, and right, given some input, and you also use it to find factors and factor long higher degree polynomials. So a lot going on in this section.